Bon, je pense qu'on peut commencer. On est déjà assez nombreux. Voilà, on est une quinzaine, plus d'une quinzaine. On va être une vingtaine qui sont déjà connectés. Donc, super. Bonjour tout le monde à cette nouvelle édition du séminaire avec Emilie et Daniela qui vont nous présenter aujourd'hui leurs travaux en cours. Les deux sont MPH candidates. Donc voilà, on est ravis. Et je ne sais pas, Laura, tu peux dire un mot de bienvenue.
Bienvenue à tous. Voilà, c'est bien de voir que ce séminaire continue à bien fonctionner. Il en reste encore, après celui-ci, encore un avant les vacances. Donc, voilà. Donc, on a Emilie en premier, vont présenter en anglais toutes les deux, non?
Moi, oui.
Voilà, dans l'anglophone. Voilà.
Ok. Du coup, je peux commencer?
Mm-hmm.
Ok. Bonjour à tout le monde. Je commence en français, mais je vais vous faire la présentation en anglais parce que je dois faire ma soutenance en anglais. Du coup, c'est plus facile pour moi. Je m'appelle Emilie, je suis dans le MPH. Du coup, je fais un master en santé publique. Je suis dans mon master 2. Et je vais vous présenter le projet que je fais pour mon stage avec Kevin dans le labo MESuRS au Cnam. Et du coup, je passe en anglais. So, my project is looking at the associations between living in flooding-prone regions or flood-prone regions and early childhood vaccination in Bangladesh. So to start with a little bit of background, we all know that climate change is one of the biggest threats to health worldwide today. The frequency and the intensity of extreme weather events are on the rise, and we have quite a bit of research looking at the direct health impacts of these weather events. We know that hospitalizations, illness, and deaths are you see a lot of increases in those things after wildfire events or air pollution or flood events. But there's a lot less research on indirect health impacts, but these are also very important. So one study that looked at indirect health impacts connected exposure to droughts with missed childhood vaccination. And then there's also another study that looked at droughts similarly, and what they found was that there was an increase in risky sexual behavior and higher HIV prevalence in regions that had experienced droughts. And those are super important to note. But I'm shifting a little bit to extreme flooding, which is actually the most common natural disaster worldwide. But there's really little research out on the impacts of extreme flooding, despite the fact that it could have various impacts on health prevention, vaccination being one of those of interest. So a little bit of background on vaccination. We all know that it's incredibly important. 4 million deaths are prevented each year because of early childhood vaccination. And we all know it to be the most effective public health intervention worldwide. So there are 4 WHO recommended vaccines that are to be administered between 0 and 15 months of age. And those 4 would be BCG, which is against tuberculosis, DPT, which is diphtheria, pertussis, and tetanus, OPV, and MCV, which is polio and measles. So now this brings us to kind of linking both of them and our hypothesis. So we wanted to look at the associations between exposure to flooding events and vaccination. And there's been, to our knowledge, no quantitative studies that have looked at this association before. There's been a few kind of conceptual papers that have explored the potential pathways in which these could be linked. And what they kind of found was all things that make sense. Migration is something that we know is increased with climate change. So when there's extreme flood events, there's more people who are having to migrate because of that, and that can interrupt routine healthcare. People are forced to relocate and find new healthcare providers, and maybe that can interrupt it and lead them to possibly miss vaccinating their children. Secondly, supply. So in various ways, the supply chain of actual vaccine can be disrupted. So either hospitals we don't have access to supply the hospitals with vaccination, or along the way supply can be disrupted. And then thirdly, one of the last main themes that came out was resource reallocation. So maybe during these extreme events, vaccination and routine healthcare, such as vaccination, gets put on the back burner for prioritizing other care or health needs of the population. So given kind of the sense of the association, our objective was to look at if children in flood-prone regions were more susceptible to being incompletely vaccinated in Bangladesh. So, excuse me, the reason we chose Bangladesh is because it is consistently ranked one of the top countries impacted by climate change. It has seen a plethora of increases in flooding events in the past years because of more intense monsoon seasons, and we know that this is only going to continue. And also, Bangladesh is home to a really large population. I think it's the 8th largest population in the world, so it's really important to look at that, and we felt it was a good place for this study. So I'm going to talk a little bit about our methods, starting with our data sources. So we have data from the Global Flood Database, which is what we use for our exposure. And essentially what this is it's a database of satellite maps that has information on all of the largest floods that have occurred since 2000. And they have a bunch of different variables available. And the variable that we used mostly was the duration of the floods. Then for our outcome, so for our vaccine variable, we used the DHS. So if you don't know what the DHS is, it stands for Demographic Health Surveys. And these are giant surveys that take place every 3 to 6 years in over 90 LMICs around the world. They've been going on for a really long time. They're quite well known. I'm sure you all know of it. And we used 5 different years for these for this variable, and we also used the children's RECODE data set. So what that means is that they create a new data set for each of the children that we have information on because they interview the mothers. And so each child is a new row, and we have all of their information as well as the mother's information. So for our exposure, so the Global Flood Database is where we took the data from. We created kind of a binary flood-prone variable. And the way in which we did this is we compiled 7 of the largest floods that have occurred since 2000 from the Global Flood Database in Bangladesh, and we kind of piled them together. And with that, we were able to create at the pixel level, which a pixel is 250 meters squared. We were able to kind of do a % number of days flooded. So we took the number of days flooded per pixel and divided it by all of the flood days in Bangladesh over the 7 floods. And with that, we kind of created a threshold of 5% to consider a zone flood prone or non-flood prone. And that 5% was to account for noise from the DHS. And then we also ran some sensitivity analyses on that 5%. For our outcome, our main outcome was a non-fully immunized child. So what that means is that all of the children over 15 months old, we looked if they were missing at least 1 dose. So if they had missed 1 dose of one of the 4 vaccines, they were considered not fully immunized, and everyone else was considered fully immunized. And on the left, we see kind of the recommended timing for each of the vaccines that we considered, which is why we have a threshold of 15 months, because we can see that measles is administered at 15 months in Bangladesh. In terms of our analysis, we started with some descriptive mapping, and then we move into univariable and multivariable analysis. using GE models, generalized estimating equation models, which accounts for clustering. It's a hierarchical model. And then we moved to IPTW, inverse probability of treatment weighting, to kind of check our covariate balance. And then we did a stratification by vaccine and calculated some absolute outcomes for easier interpretation. And yeah, on the right, you can see the covariates that we included in our analysis. So for our results, we found that 30% in our sample, 30% of children live in flood-prone regions, and 85% of children were fully immunized. So this 85%, keep in mind that that's a compilation of those years of DHS. So it's not perfectly accurate to what we see today, but it was for our sample. And then these are maps showing the proportion of fully immunized children at the administrative 2 level. And the top left is our percent days flooded variable mapped, so that you can see kind of the scale. So here are some univariable analyses. And sorry about that noise. What we can see is kind of that the children who are not fully immunized are more likely to have a lower mother education level, a lower wealth category, more likely to live in an urban area, in a rural area, sorry, and more likely to live in a zone prone to flooding. Then moving into our main analysis, so here we have the comparison between the univariable Poisson GE regression, the multivariable, and the IPTW Poisson regression. And you can kind of see that all of these estimates are well above 1, and the confidence intervals don't overlap 1 at all. So we are seeing that there is a relationship between exposure to flood-prone regions and incomplete vaccination. So when we break it down further and looking at each vaccine separately and each dose separately, on the left we have a forest plot that's showing each vaccine in black, the doses in blue, and then overall in red. And we can see that all of these show the same trend, and it's consistent with what our main finding was. So with that, we also were able to calculate the population attributable fraction, which we got 0.06. And using the population attributable fraction, we were able to make an estimate of cases of incomplete vaccination due to flood-prone regions, which for 2017 in Bangladesh, we have an estimation of 108,959. Oh, I just realized that I missed the comma on the bottom, confidence interval, please. I will change that. That is based on an estimation of the population that's not fully exact as of right now. It's something that needs to be finalized when we find the final data that we're going to be using for this calculation. Just to speak really briefly on the sensitivity analyses that we did, as I mentioned before, we did sensitivity analyses on the exposure. So the result that I'm showing here is the exposure quartiles. Instead of having a 5% threshold, we broke down the exposed PSUs, so principal sampling units, created quartiles, and then ran analysis on each of those quartiles. And across all of them, we can see a similar trend, which is reassuring. We also changed the threshold to 5% or to 10% and to 2%, and we also saw the same trend with that. And then we also did an analysis on exposure as a continuous measure, which we did at the PSU level, and that also showed a similar trend. Then we did an analysis on age, so we wanted to see if 15 to 24 months old had different effects than 24 to 48, and we saw that there was no difference. And we did monsoon season analysis where we looked at if a child was born during monsoon season. And then we also did a mixed effects model instead of a Poisson GE just to confirm. And all of these are showing the same result. To have a little bit talk about discussion. So children, what we really saw in our study is that children in flood-prone regions are less likely to be fully vaccinated. And as I said before, vaccination is incredibly important. So understanding this association has a lot of public health implications. Also, floods are increasing with climate change. And so this shows that we really need to build our capacity build during flooding events for these particular sectors, and potentially launch catch-up vaccination campaigns or other things to kind of fight against this association. Some strengths of our study would be the large sample size. We had over 10,000 children who were between 15 months and 5 years in our sample. Also, the DHS is representative, so they provide sampling weights so that we can actually extrapolate our findings to Bangladesh as and not just the sample size. And also the DHS has really consistent data. So they have over all of the survey waves, they have 97 to 99% response rates, which is huge. And that's also a strong point. Some limitations would be we potentially had misclassification of the exposure, but we did run, that would be because of the DHS adds noise to their GPS estimates just for data protection. But we did run a lot of sensitivity analyses on that, and we're pretty confident in our results. If anything, it would be an underestimation. Also, not all of the variables of interest were available, so distance to a health facility was not something that we can account for, as well as attitudes towards vaccination. Those were just not available in the DHS. So that kind of brings us to future directions. It would be interesting to look at that with those additional variables. Also, it could be interesting to look at other flood-prone countries and see if the association is still there. So overall, I just wanted to bring this kind of to talk about the climate injustice that this is kind of showing. Bangladesh omits a very, very small percentage of the world's greenhouse gas emissions, but as this study shows, there's huge impacts on the population, and flooding is increasing in frequency and worsening in severity, as I mentioned before, which just highlights the need to kind of consider better, consider routine health in a more consistent way in disaster protocols and in emergency situations. So that is all. If you guys have any questions in English or in French, I'm happy to respond, or any comments. Sorry if I went a little bit over time.
Thank you very much, Emilie. Great talk. The floor is open for discussion. Simon?
Yes, hello, thank you. I was curious to know, you mentioned that you looked at a bit older kids. Do you know if maybe I didn't really understand what this covered? Do you have any information on whether there was any catching up on the vaccine schedule after 15 months? I mean, was there a way to identify if it was just a delay or just missing out completely on the vaccine? Or because we can imagine that people move from their place of residence and their healthcare provider area, and then they come back after the flood is over. So do you have any information on that?
So we don't have information on the timing of the vaccine, so we don't actually know when any of the children were vaccinated. We just know if they were. And so looking at that was kind of what we were trying to look at through splitting it by ages, was seeing if the association was still there when we looked at only older children, because if the association was not there anymore, it would kind of signify that there was a catch-up vaccination happening. So that was kind of to show that, but we weren't really able to look more precisely at when they were vaccinated. And also, it's interesting when in a lot of exposures to floods, you mentioned that they leave and they come back. in a lot of situations in Bangladesh, they don't come back. They move, and a lot of the time when they move to other regions that are also flood prone. So it's these migration patterns that are just consistently pushing back, but disrupting a lot of healthcare, and that would continue. The association would continue through the ages if that were the case. I don't know if that answered your question.
Yeah. Thank you.
Thanks. Other questions, please raise your hands. Maybe in the meantime, I have a question. So on this eligibility criterion there, so you included children starting age 15 months, right?
So that was for our like non-FIC, so not fully immunized child. Yes, it was between 15 months and 5 years. But when we looked at all of the vaccines that were provided earlier, we included younger ages. So our population increased as we looked at the vaccines that were given earlier. So BCG tuberculosis, for example, is given at birth. We had a sample size of 18,000 for that model, because we were able to include all children that were available, rather than just 15 months and older. At
which age did you include them then for this analysis on BCG?
We included all children for that one because it's given at birth.
Okay, so it's really, BCG is really only about vaccination at birth. It's not about vaccination later. And then DTP is also about vaccination recommended, like if for the second dose of DTP, you would include, let's say, starting week 9, you would include everybody for the second dose evaluation.
Yeah, so we gave like a 2-week buffer, but yeah, we included all the people that were eligible for that vaccine in the analysis.
Which is maybe a little bit too strict because, there's the problem that vaccination, most doses are not timely. Actually, the majority of doses is not given in a timely way, and I imagine in Bangladesh as well. Yeah. Okay, and then maybe just a question that maybe a reviewer could ask: why does BCG stand out? Why is it BCG and not other vaccines that stand out as being particularly sensitive to flooding?
Are we speaking about?
Well, it seems that the effect is consistently stronger for BCG and the different, also the quartile analysis.
From what I understand, BCG, since it is the largest sample size in our study, I feel like it has the most power to show that association. I think it would be difficult to say that there's actually a strong difference between BCG and the other vaccines. When you look at the confidence intervals, they all overlap and they're showing a similar trend. But I don't know exactly what else I would say.
Yeah, a good point about the sample size, but this would not explain why it's always a little bit the trend is higher. So I agree that it's not significant, but I guess the problem is BCG is given at birth, so it's like 1 day or a period of 3 days or something like that. Whereas the other vaccines, well, you do have at least a buffer of 2 weeks and so on, and probably there is a lot of catch up later on and so on. So that's what I could imagine. And maybe the same question for measles, because measles is recommended at age 15 months, and then it seems to be, a little bit short maybe to already include. I imagine that it's given much later.
Yeah, it's a good point.
So just that maybe that's something that came to my attention.
Yeah.
Anybody else, please? Hands up.
Sorry. Now you're making a good point with that, Judith. And actually, one figure that is a bit surprising to me is the fact that non-FIC in that graph is actually kind of the lowest prevalence ratio. So we would have expected that it kind of integrates the effect of each doses, and this is something that is a bit surprising to me, and at the moment we cannot clearly explain.
You speak about measles, MCV.
I'm speaking about the last one, the red one, the non-FIC, which is the fact any of these any of these doses. So
theoretically, it's something going on with the timeliness and so on.
Yeah. Good point. Yeah, no, we're right about that. Maybe we should look at children above 18 months to allow for kind of delay.
Yeah, that's usually what coverage surveys do. That they leave quite a larger buffer, not only 2 weeks, but much larger, because you could look up like publications on timeliness of vaccination. There have been some good analysis, global analysis on this, and it's it's very sobering. So, it's just the recommendations are a vague recommendation. Children get vaccinated much later.
That's a good note. Thank you.
Another point from anybody, maybe about the methods or something? No?
Yeah, perhaps something. I didn't really. Did you see any exposure dose effect relationship between the frequency of the floods? Because I think that's the exposure that you measured. In one of your sensitivity analysis, I think you mentioned that you did not just look at children who were exposed to over 5% of the time in floods, or 5% of the years, I'm not sure. But did you see sort of a exposure dose effect relationship? The more frequent the floods, the more likely you are not to be fully immunized. Did you observe anything like that?
So when we looked at the quartiles of exposure, so when we looked at all of the PSUs that were exposed and we split into quartiles and ran on each of the quartiles, we didn't really see a dose-response relationship. We just saw kind of a consistent relationship. But when we did do the kind of ecological study, so at the PSU level, looking at percent days flooded as a continuous variable, we kind of saw a little bit more of a dose response relationship, where as percent days flooded increase at the PSU level, the percent of children who are not fully vaccinated also increased. But I don't know if we would be confident in saying that it was a dose response relationship. I don't know, Keaton, if you have anything to add for that.
No, this is also something we should explore, but here we have this kind of issue about the fact that there is some noise in the GPS data of some voluntary noise to preserve anonymity in the DHS data, in the GPS DHS data, and in the kind of the results you show with the quartiles of exposure. Here, I don't think we see any dose response, but when we look more at an ecological level, we can see this dose effect relationship. So there is still something we should better understand here.
Because your marker is the number of days that are flooded, or
yeah.
Okay.
It's the percent number of days flooded. So we had the 7 maps, we layered them, and then we kind of summed all of the days that had floods in Bangladesh for those 7 maps, so those 7 flooding events. Okay. And then for each PSU, we calculated the number of days that PSU experienced a flood and then divided it by the total number of floods. So it became like a percent days flooded, which is a proxy for kind of like the severity of the flood. So how often is that going to be repeatedly exposed to flooding, or because usually
all the children are exposed to at least 5%, like at least 5% of the days they're in a flooded area.
So that's the complicated part because of the DHS noise. So what we originally wanted to do was take any exposure to floods and consider that as flooding prone or flood prone. But when we did that in considering a kind of buffer for the DHS geography, like the geographical estimate, it created, since what happens when you take a buffer for the PSUs, it created this big radius, and it led to like a lot more of the PSUs being considered exposed if we had just 1% or any percent flooded than was actually accurate. in terms of the actual number of PSUs exposed. So we chose 5% to kind of reflect the number of PSUs that actually were flooded in another paper using a similar method. And that's why we chose the 5%. And then we ran sensitivity on that. We chose to kind of do that rather than ignore the noise from the DHS and just go with knowing that we have noise and just ignoring it. But I don't know, that could be also.
But it's a high cutoff, I guess. I mean, because 5% of the days sounds like yeah, every 20 days you're going to be like with your feet in the water, if I understand right.
But it's 5% out of all of the days that were flooded. It's not 5% out of all of the days. It's 5% of the days that were flooded.
Within the flooding events. Yeah. Okay.
And also, it's because of the noise. It would be 5% of the area, so it's not perfect.
Because what you mentioned, I think it raises the concern of how precisely you can adjust on the socioeconomic status and the quality of the urban infrastructure and the flooding, mitigation. I mean, these are really just like knowing how the field works, which I'm not familiar with at all. But that's probably one of your main concern. And I'm a bit surprised that you don't see a dose-response relationship, because if it were really just connected to the flooding, I mean, you know what I mean? I mean, if you're in a flood area, it means you're also exposed to other fragilities and so on, and maybe you're less prone to be vaccinated for other reasons, which you cannot really account perfectly for. But I mean, that's one of the concerns that I could raise, seeing what your report, but maybe you have other ways to,
Yeah, I don't know. I mean, I think that's a good point. But yeah, I don't know if I misunderstood, but you said that we wouldn't really be able to assess the demographic variables, but those are individual level data that's collected.
Yeah, I mean, there's always the concern of residual confounding, but and if flood were really the only risk factor, sort of, then we should have something more of a dose response relationship, but maybe not, and maybe it's enough that every once in a while the fridge doesn't work, and then you have no vaccine, and then you don't catch up. I mean, I don't know, but yeah.
Yeah, I think the point is maybe have some ecological infrastructure related indicator. So I can't remember whether you had any in your list, but you could look at whether you have I don't know, whatever density of healthcare workers or school, I don't know, or housing and so on. But it seems indeed that there's some correlation, maybe some confounding going on with, there could be some confounding with just infrastructure and so on. Which then also feeds back to this birth dose question. So maybe more births are given outside and so on. So yeah, so you have fewer urban, but there may be more infrastructure-related issues.
Yeah,
but
so
I'm afraid we have to stop here because we have the second talk by Daniela. But yeah, a great interest your talk. Thanks, and congratulations already. Not too early, but well, okay, but you'll be fine, I think. And Daniela, if I hand over to Laura also, maybe. Laura, if you want to take over. Si tu veux animer la discussion.
Well, the discussion. Then at the end, I'm sorry, but I'm going to have to leave early at the end because I have a class to teach just afterwards. So I might not be the best person to. But yeah, thanks, Emilie, and everyone who has questions. And Daniela, the floor is yours. So we can see your presentation. Maybe if you put it up. Yeah, can you put it in full screen? Or?
Yeah. Can you see it?
Yeah, good.
Okay, wonderful. So during the next minutes, I will be talking about a systematic review and meta-analysis that we conduct to look at the natural history of chronic hepatitis B infection according to the viral load and the LT levels. It's crucial to understand this if we also want to understand who might benefit the most for treatment and also who might be eligible for treatment. So for this to answer this research question, we had a team a part of the team is based here in Pasteur and the other part is based in the UK. So as background, back in 2015, the WHO released their first hepatitis B treatment guidelines. And alongside these guidelines, they also set very ambitious global viral hepatitis B elimination targets. And to meet these targets, it is important to scale up antiviral therapy coverage in people that is infected and that meet that criteria for treatment. Currently, the decision of who receives treatment and who does not receive treatment is based on targeting those individuals with higher risk of disease progression. And there are different algorithms that can be used to identify those individuals. However, since 2015, there has been new and emerging evidence on HBV natural history and also on treatment efficacy in previously ineligible populations. And this is why we aim to review this new and emerging evidence. And also we aim to estimate a summary estimate of the incidence rate of developing clinical outcomes without treatment and without cirrhosis, because those individuals are already eligible for treatment. And we did this stratifying by viral load. Currently, according to the last guidelines, individuals with a viral load above 20,000 are eligible for treatment, but the question is whether some individuals with a lower viral load might also benefit from receiving treatment. So that's why we decided to stratify according to the viral load and also according to the ALT levels. So for the methods, sorry, the slides are not really loading that fast. Now, so this is the summary of the research question that I already mentioned. So first, for the population, we consider individuals with hepatitis B without cirrhosis and without concomitant therapy, who had both quantification of viral load and also ALT. For the intervention, we consider no treatment, but we also included studies that provide any treatment during the follow-up, but not at baseline. And we didn't have any comparison. And for the outcome, we consider the risk of incidence or incidence rate of clinical outcomes. We consider hepatocellular carcinoma, cirrhosis, any cause of death. We also consider liver-related death. We also consider HBs seroclearance, HB antigen seroclearance, fibrosis progression. And we stratified participants according to the viral load, as I already mentioned, and the ALT level. Then we were able also to do a meta-analysis using mixed methods model. So for the data search, we use PubMed, Embase, Web of Science, and the Cochrane Library. We conducted the search in February of this year. And for the search strategy, we use as key terms hepatitis B. We use also parameters that were used to stratify participants and the clinical outcomes. Additionally, we also consider the study design, and then we use a random effects model, as we assume that there was a high heterogeneity between the studies. So that's why we decided to use this model. So here's the flowchart for the selected references. So initially, we retrieved a total of 13,000 references, and all of them were screened by 2 reviewers. After that, we identify around 700 that were potentially eligible. Out of that total, we included 78 published references, and we also identified 2 reports that were not published, but we identify the results thanks to EPSANET, and these reports correspond to studies conducted in Ethiopia and in the Gambia. So these are the general characteristics of the included references. Most of the studies came from the Western Pacific region. most of the around half of the studies were published after 2015, which was the year, as I mentioned, that the WHO released their last guideline for treatment of hepatitis B. Regarding the study population, most of the studies were conducted in adults. Most of the studies were prospective cohort studies. Most of them did not perform a systematic assessment of the level of fibrosis in participants, and most of the studies had a long follow-up of 5 years or more. We assessed the risk of bias using the Newcastle-Ottawa scale. With this assessment, we noticed that most of the studies were rated as with poor quality. This was mainly because, like very frequently in cohort studies, the ones that we identified, the authors do not report the adequacy of follow-up, so they don't systematically report how many patients were lost during the follow-up. So for the results, first I'm going to present the results according to the viral load stratification. So in this first forest plot, the outcome is hepatocellular carcinoma in adults according to just a single viral load assessment. So here the groups that you can see are according to the viral load. So this first group is for patients with a viral load below 200, then this one is below 2,000, then this one below 2,000 and 20,000, sorry, then between 20,000 and 200,000, and then above 200,000. So currently, according to current recommendations, all these last two groups should be eligible for treatment, and it's interesting to see that actually these two groups have the higher incidence rate. This first plot reports the incidence rate per 100 person years. So these two groups have had the higher incidence rate, and they are currently eligible for treatment. But then the question is like whether some of the individuals that have a lower viral load might also benefit from receiving treatment. There is currently a lot of discussion about whether everyone with a detectable viral load should be treated or not. So it's interesting, like we found that for this first group below 200, the incidence rate was relatively low, was 0.12. And then, which is quite similar as compared to this group below 2000, which was 0.16, and the confidence interval for both groups overlaps. That means that there's no significant difference. There's not a statistically significant difference between these two groups, which is interesting because most of the participants that are below 200, most of them are undetectable, have an undetectable viral load. And then it's also interesting that these two groups have a quite lower incidence rate as compared to this other group between 2,000 and 20,000, which currently is not eligible for treatment according to the guidelines. This analysis is also for HCC in adults, but according to several different viral load assessments. So this analysis was limited mainly because of the low number of studies for these last two groups, but it's interesting that we found a significant number, like we found nine reports for patients with a viral load below 2,000. And it's interesting that the incidence rate is lower as compared to the same group when you only do one assessment for viral load. This might be because you are able to better characterize the patients, and they tend to have like a lower incidence rate. Also interesting that here in this group, there was not a significant source of heterogeneity for the pool estimate. Now this forest plot is for cirrhosis, also a single viral load assessment. So here we also can see a similar pattern as compared to HCC. As we increase the viral load, the incidence rate also tends to increase. But here we did find a statistically significant difference between this group below 2,000 and this group between 2,000 and 20,000. So that's quite interesting. Then again, we had a high heterogeneity for most of the groups, And yet we were able to explain that heterogeneity due to other variables that we present here in the forest plot, such as, for example, HBe antigen status, whether all participants were positive, negative, or the group had a mixed pattern, and also by the ALT category. So those studies that tend to include participants with any viral load or with a very high ALT value tend to also report higher incidence rate. So this forest plot now, this analysis is for all cause of death. Here we did not find any significant difference between all the strata. It's mainly because here we are observing all cause of death, so this is not specific at all. But we also assess liver-related deaths, and for this is interesting that, again, as you increase the viral load, also liver-related deaths, the incidence tends to increase as you increase the strata. So that's interesting. And then we also did a stratification by ALT levels. So currently the recommendation is that if you have a patient with hepatitis B, you need to do follow-up with ALT. So for this, the groups are based on the ALT level. So this group is below the upper limit of normal. Usually it's around 40. Then for most of the studies, then the second group is between 1 and 2 times the upper limit of normal, and the third group is above 2 times the upper limit of normal. Here we have, in this group, we have a high heterogeneity, again, for the same factors that I mentioned earlier, such as, in this case, we are looking at the ALT, so in this case, it might be explained because of the ALT, the viral load, sorry, and then also because the HBe antigen status of the participants. Then this analysis is also for ALT assessment, but when you have multiple assessments, which is the recommendation. And it was quite interesting that this heterogeneity that we saw in the other forest plots tend to decrease. And still we had like this outlier, but it was a very small study, with only 11 participants. So this might support also recommending like regular ALT assessments to have a better characterization of individuals with hepatitis B. Then we also perform an evidence, like we assess the evidence level according to grade. So for this, we mainly consider 4 variables, which is risk of bias, inconsistency, indirectness, and imprecision. Unfortunately, most of the estimates have a low or very low quality of evidence, mainly because of the heterogeneity that we already saw, and also like the broad confidence intervals that we estimated. Only for liver-related deaths, we found that the quality of evidence could be graded as high. So it's interesting that we found a substantial number of estimates for different viral load strata, especially for clinical outcomes that are relevant, such as HCC or cirrhosis. It's interesting that there is no evidence for a statistically significant difference between the groups that have a viral load below 200 and below 2000, which suggests that they might not be really different between these two groups. So it opens the floor for the discussion of whether everyone should be treated. And then we also found that for viral load levels above 2000, there was a dose-response relationship, as we saw in the forest plots, between the viral load at baseline and the incidence rate of both HCC and cirrhosis. Then regarding the ALT stratification, when you do a single ALT assessment, you have, we had a high heterogeneity, but as we compare this result with multiple ALT assessment, the heterogeneity decreases, and that's also nice. So then regarding the limitations, we were not able to adjust for potential sources of heterogeneity, including other comorbidities such as diabetes, alcohol consumption, or other potential risk factors for HCC. We also were not able to adjust for co-infection of other co-infections such as hepatitis C, HIV, hepatitis D. But yet most of the studies excluded these participants. And another big limitation was that most of the studies were from the Western Pacific region, and we have a limited number of studies coming from other regions such as Southeast Asia, Eastern Mediterranean region, Latin America, and also from Africa. So that's my presentation. Now I will be happy to answer any question.
Thank you very much, Daniela. I don't know whether Laura, tu es toujours là. If you want to take over or.
J'étais en train d'écrire un message pour dire au revoir. Thanks, Daniela. Goodbye, everyone. Sorry.
Yeah, okay. Au revoir, Laura. Donc, voilà. Des volontaires pour poser des questions, s'il vous plaît. Voilà. Juste, voilà, Kevin, oui, c'est une main, d'accord, ok.
On est dans la salle commune, donc ce n'est pas moi qui dois rallumer le micro. J'avais une petite question peut-être plus sur une question de contexte et une question de méthodo. Celle de contexte.
Can you ask in English, Kevin? Parce que
sorry, excuse me. So I have two minor questions. One about the context, the epidemiological context of HBV. Why did you find so many studies from Western Pacific? And the second question is about the higher proportion of poor quality study. Did you consider excluding them from the meta-analysis? Or?
Yeah, well, regarding the first question, it is because there are several cohorts that have been conducted in the region, also because of the high prevalence that they have. Like, so we have many studies coming, for example, from China, Taiwan, and yeah, that's the main reason. Also, there is a huge lack of evidence of other regions that also need research, such as Africa, where also the prevalence is significant. Then regarding the second question, yeah, we're planning to do kind of sensitivity analysis according to the quality of evidence, just to see if if the results are consistent with the level of evidence. Yeah.
So the geography of the studies overlaps the epidemiological distribution, the non-geographic distribution of the disease.
Yeah.
This is not okay. Thanks.
Mm-hmm. Thank you.
Simon?
Yes, thank you, Daniela. I just you present the risk of the incidence rates.
Yes.
I guess it's hard to compare for some of the outcomes because, of course, they're going to have more liver fibrosis or HCC. But was there any way, maybe for overall mortality, to compare this with the underlying risk in the source population? I mean, is this something that you considered? Because it's hard sometimes to know if it's low or if it's a bit higher. If it's a bit high, it's yeah.
Actually, we were discussing about that a lot, but like, for example, the issue with HCC is that it's a rare event, even for people with hepatitis B, so it's not really comparable. And then we also, like, the other strategy we thought about was like, what about comparing with other diseases? Like, I don't know, let's look at hypertension and whether when you decide to treat one threshold or the other for the blood pressure. And then again, it's quite a different disease, and the treatment is totally different. The course of the disease is different. Like, it was kind of comparable. The net number, like, without adjusting for anything, the absolute numbers, the absolute incidence rate is comparable to cardiovascular events in people with high blood pressure. But again, you have to be careful with that kind of comparisons because the disease is totally different. So yeah, that was the only comparison we were able to do. But yeah, you have to be careful with.
So for example, the incidence of HCC for people with low viral load, that was you said something like 0.1 per 100 person year. So that means yeah. So we need to follow up 1,000 people for 1 year, or one person for 1,000 years to see one event. Is that
Yeah, exactly. 0.13, yeah, and then for the other one 0.16. So yeah.
And that would be considered rather low, I guess, right?
Yeah, exactly.
Okay.
Mm-hmm.
Ok, merci beaucoup à tout le monde. Bon week-end.
Merci
Merci.
beaucoup.
Et donc, à bientôt. Et bon courage aux étudiants qui, good luck for the students, of course, for the defense of your work. Bye-bye.